All right. So a system of inequalities is a collection of two or more inequalities with the same unknown values. So remember we talked yesterday about how a system of equations is like two lines where they cross. So where they cross, they either cross in one place, no place, or every place. A system of inequalities is two inequalities graphed one on top of the other, and the place that where they match is the double shaded area. Okay. So and this should technically be like inequality 1. And this should be inequality 2. So to graph a system of inequalities, you are only responsible for knowing how to graph systems of inequalities, okay, not systems of equations. I'm sorry, you don't have to do anything else. Systems of inequalities, all you have to be able to do is graph, okay? So what you're going to do is we're going to graph and shade the first line, graph and shade the second line, and then to find the solutions, we're going to look for where they're double shaded, all right? We should all be able to graph this line. When I see this, I know, we're using rulers. There's nothing to read or underline per se, but we can list what we know. So tell me, what do I know about the slope of this line?
That's 2.
It's 2, which I can write as 2 over 1. 2 is my rise, and 1 is my run. I also know the y-intercept. What's the y-intercept?
1.
It's 1, right? Because there's my b right there. Okay, looking at the inequality sign, what kind of boundary line do I have? Solid or dashed? Solid. Because I have or equal to, that means I have a solid line. And am I going to be shading above or below?
Above.
Above, because greater than is above, less than is below. So we're going to shade above. So I'm going to plot those points now. So I'm going to start at y equals 1. I'm going to rise 2, run 1. You don't have to put the dots in every place, but I like to. I don't know why. It makes me happy. I'm kind of zen. If I'm doing it, you should be doing it. Wait. Did I mess up? Maybe? Nope. Looks good. Okay. And then when you're done, you can connect the line if you can find your ruler, which you probably can't because you lost it along with all the rest of your stuff and your marbles. Okay. Okay. There's a couple of rulers right there on the floor if you're feeling lazy. Okay. So here's my line, and remember it goes off in all directions. It's solid because I have that or equal to, and I'm going to shade above. So again, I'm just going to shade like that. Okay? So that's the first one. Okay, now you can use, we're going to shade in 2 different directions, but what you could also do if you wanted to is you could use 2 different colors. All right, so for this one, I'm going to shade, now, I know you guys are going to want to do the thing where you just do the cover-up method, but we're not going to do that. First of all, this one won't work well with the cover-up method because 8 divided by 3 is like 2 and 2/3. Ain't nobody going to want to graph that, okay? So we're going to convert this into slope-intercept form, all right? To convert into slope-intercept form, the first thing I want to do is I want to make sure that I isolate my y variable because slope-intercept form has y by itself. So I'm going to subtract 3x from both sides. Zero it out. I have 2y greater than or equal to negative 3x plus 8. If you put 8 minus 3x, is that okay?
Yes.
Absolutely. It's the same thing. It's totally okay. All right. Now I'm going to divide by 2. At this point, your math senses should start to tingle. All of your alarms should start to go off. Something should be freaking you out because we're dividing. You should always go on alert when we divide. Because when we divide, if we're dividing by a negative, we might have to flip the sign. So even if you're not, I want you to always be kind of like, oh, do I need to flip the sign? Just think about it. Now, if you're dividing a negative number, that's not what matters. If your answer is negative, that's what matters. What matters is the number that I'm dividing by negative? Is it?
No.
No, because that's a positive 2, right? So I don't care about that, okay? So these cancel out. Negative 3, I have negative 3 half x. Plus 4. Now, I'm going to leave that as negative 3 half and not write it as negative 1.5 because I'm about to graph it. I want it to stay a fraction because I don't want to be rising 1.5 and running 1. I want to rise 3 or fall 3, run 2. I like it as a fraction because it makes it easier for me to plot it. Okay? So just like I did up here, I'm going to write down my slope is negative 3 over 2. My y-intercept is 4. My sign is greater than or equal to, so just like this one, since it's or equal to, it's solid, and I'm going to shade above. What else can I notice about the slope?
It's Negative.
It's negative, so I should have a line going downhill, just kind of like something for me to think about. Okay, let's go ahead and plot that line. So negative 3, 2, negative 3 over 2, negative 3 over 2. Just keep saying that. And again, you don't have to complete the line in the other direction. It just makes me happy. How many of you are uncertain about which way to shade? Like whether you, what does shade above, what does shade below mean? Anybody? Okay. It's actually pretty easy to figure out what you do if you're not sure. You take your pencil or your pen or whatever, you put it on the line. If it says shade above, you're going to draw an arrow pointing up. If it says shade below, you're going to draw an arrow pointing down. Since mine says shade above, I'm going to put it on the line and draw an arrow pointing up. That's the area I shade. I shade the area that I pointed at. So if I was shading below, I'd have an arrow down there, and I'd shade the area that side of the line. Okay? So since I've got this now, I'm going to shade. Now, if you're only using one color, this is what I was talking about how we want to shade in different directions, because then what you end up seeing here is hash marks in the middle. So where it's double shaded. So instead of lines going in one direction or the other, you see lines, you see X's. Okay? Now, because I'm special and extra, I like to go ahead and highlight the area that's double shaded. I just like to make it easy for me to see. I mean, it's impossible to miss right now where my solutions live. Okay? So what this means is any points that are in this shaded area are going to make the inequality true. So far, so good? Let's try a couple points. What about 4, 2? Well, let's plot that point. Over 4 up 2. Is that in the double shaded area? No. It's part of the solution set for this inequality, but it's not part of the solution set for the system because it's not in both. It's not in the double shaded area. So this one's a no. What about 2, 5? Over 2, up 5. What do we think?
It's on the line.
It's on the line. Am I allowed to have points on the line?
Yes.
Yes, because it's solid, because it's or equal to. So this actually is. Now let's pretend you're not sure. And you want to check mathematically. Well, let me show you how to do that. Okay, you're going to take this coordinate, this 2, 5, and you're going to plug it into this equation. So y is 5. 2 times x, which is 2, plus 1. Well, 2 times 2 is 4. 4 plus 1 is 5. Is 5, I'm sorry, that's greater than or equal to. Greater than or equal to 5?
Yes.
Yep, so it's true for that one. But in order for it to be a solution to our system, it has to be true for both. So let's look at this one down here. And I'm not going to use what I transformed. I'm going to use the original just in case I made a mistake. So 3 times x, which is 2, plus 2 times y, which is 5, should be greater than or equal to 8. Well, 3 times 2 is 6. 2 plus 5 is 10. 16. It's definitely greater than or equal to 8. So I proved by looking at the shaded area, double shaded, and by actually plotting those points. And I'm sorry, by substitution. Let's try a couple more. How about 1, 3? Do we think that's in our solution set?
No.
Why not?
Yes.
What if you're not sure? What can you do? You can check by substituting. But I will tell you, it's on both lines. It is actually the intersection of the lines. And since both, now, if one of, like, for example, if the orange line was dotted, was dashed, it wouldn't work. But since they're both solid, any point on the line is also part of the solution set. Okay, so this one actually is a solution. But again, if you're like, I don't know, it looks kind of close, I'm not sure, then do substitution like we did here. Okay? How about 0, 8? 0 up 8. Wow, that is right in the middle of our solution set. We'll give that a big old check mark. What about this last one, 0, 1? No, it's on the line of the yellow one, so it's part of the solution set for the yellow, but it's not part of, for the orange, but it's not part of the solution set for the system. Okay? All right. So that's how we graph and solve systems of inequalities.